Good evening, sir.
Good evening. I think we have finished reaction with metals in acids. Reaction with metals we finished. Then reaction with metal carbonates and metal bicarbonates we finished. Yes or no? Hello, students in meeting. We have finished reaction of an acid with metals, reaction of an acid with metal carbonates, metal bicarbonates. Right?
Yes, sir. Yes, sir.
Okay. Today we will study reaction of acids and bases. Reaction of acids and bases. Today we are studying reaction of acids and bases. Okay. So that is also one of the method to detect the acidic nature of a substance. If a particular substance is acidic in nature, if it reacts with, if it is acidic in nature, it has to react with base, correct? So when acid reacts with base, that reaction is called neutralization reaction. Okay. So let us take one simple example. Sodium hydroxide is a base. Na, yes or no? Sodium hydroxide is a base, NaOH. When it reacts with hydrochloric acid, HCl, it gives what? NaCl plus H2O. It gives NaCl plus H2O. Now, NaOH, when you prepare NaOH solution, aqueous solution, NaOH aqueous plus HCl aqueous plus NaCl aqueous. Okay. All these are aqueous solutions. When we prepare NaOH aqueous solution, what happens? Yes, NaOH that dissociates completely into Na plus OH minus. Correct? It dissociates completely into Na plus and OH minus. Similarly, if you take HCl, that also dissociates completely into H plus Cl minus. NaCl, that also dissociates completely into Na plus Cl minus. Correct? Now this reaction, NaOH plus HCl gives NaCl plus H2O. that reaction also can be written as NaOH that dissociates into Na plus aqueous plus OH minus aqueous, right? So Na plus aqueous plus OH minus aqueous, then we can write HCl. HCl means H plus aqueous plus Cl minus aqueous, because in aqueous solution they dissociate completely. So here I can write H plus aqueous plus Cl minus aqueous. Okay. Na plus aqueous plus OH minus aqueous plus H plus aqueous plus Cl minus aqueous gives NaCl means Na plus aqueous plus Cl minus aqueous plus H2O. In this Na plus in NaCl came from Na plus from Na1. So this Na plus and this Na plus get cancelled because this Na plus is the same Na plus which were there in Na1. Now the Cl minus present in NaCl that came from Cl minus present in HCl. So that cancel out. Now what is there? This is H plus plus this is OH minus gives H2O. H plus plus OH minus gives H2O. This is neutralization reaction. When acid reacts with base, that reaction is called neutralization reaction because H plus from acid that reacts with OH minus from base gives water. Hope that's clear. Hope that's clear, everyone.
Yes, sir.
Okay, can you please write down this? Can you please write down this? ಬರ್ಕೋತಾ ಇದ್ದೀರಾ? Shall I erase this?
Yes, sir.
Everyone, shall I erase this?
1 minute, sir.
Or
Yes, sir.
reaction of acids and bases. Okay, so you can write down the point. When acid reacts with base, When acid reacts with base, the reaction is called when acid reacts with base, the reaction is called neutralization reaction. When acid reacts with base, the reaction is called neutralization reaction. All neutralization reactions in all neutralization reactions, the reaction is always between H plus of an acid and OH minus of a base to form water. So in all neutralization reaction, the reaction is always between H plus of an acid and OH minus of a base to form water. All neutralization reactions are exothermic. That means all neutralization reactions they liberate heat. Okay. So all neutralization reactions are exothermic. That means they liberate heat. When neutralization reaction is between strong acid and strong base. So when neutralization reaction is between strong acid and strong base, the amount of energy released is always constant. Is always constant. See here we know that all neutralization reactions are exothermic, right? That means they release heat. Heat is nothing but energy. They release energy, right? All neutralization reaction, they release energy. If the neutralization reaction is between strong acid and strong base, it may be like between HCl and NaOH. It can be between KOH and HCl, right? So all strong acids and strong base. So if it is between strong acids and strong base, then any which ways it is exothermic. That means it releases heat. So if it is between strong acid and strong bases, then the amount of heat released or energy released is always constant. 52.2 kilojoules of energy will be released, and that value is not required for you. I'm just telling you. So the amount of heat released is always constant if the neutralization reaction is between strong acid and strong bases. Hope that's clear.
Yes, sir.
The amount of
Yes,
energy
sir.
is always constant. This is because actually why it is always constant? Neutralization reaction between neutralization reaction between strong acid and strong base is always H plus aqueous plus OH minus aqueous, H plus aqueous plus OH minus aqueous gives H2O liquid. Since it's always between H plus and OH minus to form H2O liquid, the neutralization reaction between strong acid and strong base is always constant. Shall I raise the first point?
Yes, sir.
Second point?
Yes, sir.
So you can conclude from all these points in neutralization reaction. In neutralization reaction, acid reacts with base to form salt and water. So in a neutralization reaction, acid reacts with base to form salt and water. Can we take up two examples? Can we take up two examples? Hello everyone, can you hear me?
Sir.
Shall I erase this, everyone?
Yes, sir.
We'll take up few examples. First one already we discussed. First example, NaOH plus HCl aqueous gives NaCl aqueous plus water. NaOH plus HCl gives NaCl plus H2O. Correct? Huh? Any other example? ಇನ್ನೊಂದು ಯಾವ್ದು ತಗೋಣ? Can we take up QOH? QOH aqueous plus HCl gives HCl aqueous plus H2O. Or we can take up NaOH aqueous plus HNO3 aqueous gives NaNO3 aqueous plus H2O. NaNO3 aqueous plus H2O. Or we can take NaOH aqueous plus H2SO4 aqueous gives what? Yes, it gives what? NaOH plus H2SO4.
Na2SO4.
Na2SO4, correct. Sodium sulfate, correct, no?
Yes, sir.
Na2SO4 plus H. Similarly, we can take barium hydroxide, BaOH twice plus which acid we can take? Yes, HNO3 can I take? Barium hydroxide aqueous plus
Sir, is above
HNO3.
equation balanced, sir?
Pardon?
The above equation not balanced, right, sir?
Okay. Na2SO4 means 2 NaOH. Then 2 H2O, right? Yes, thank you. Now it's balanced, right?
Yes, sir.
It's balanced, no?
Yes, sir.
Okay. Barium hydroxide plus HNO3 gives is barium. Start this 2, therefore it will be NO3 twice. NO3 twice plus H2O. NO3 twice plus H2O. Since it is NO3 twice, there is 2 HNO. Correct? Then 2H, 2H, 4H, 2 oxygen atoms. So it should be 2H2O. Yes or no? Then BaOH twice aqueous plus H2SO4 aqueous gives what? Barium sulfate, BaSO4 aqueous plus barium sulfate, 2H2O, barium sulfate plus 2H2O. One more reaction you can take, KOH aqueous plus carbonic acid, H2CO3 aqueous. KOH plus H2CO3. It gives potassium carbonate, K2CO3, K2CO3 plus 2O. K2CO3, that means it should be 2 KOH, right? K2CO3, 2H, that means here it should be 2H. Reaction is balanced. All these are the examples for neutralization reaction. When acid reacts with base, that reaction is called neutralization reaction. And remember, neutralization reaction is always exothermic. That means in neutralization reaction, there will be liberation of heat. And if acid is also strong acid, then base is also strong base, then the amount of heat liberated is always constant. Any strong acid you can take, any weak acid you can take. So now the question arises, sir, what are strong acids? What are strong bases, right? That is what we'll learn next. Next topic, strong acids and strong bases. Okay. Hope that's clear. Shall I erase this?
Yes, sir.
Everyone, shall I erase this?
Yes, sir.
Yes, sir.
Okay, thank you. Next is strong acids. What are all strong acids? What are all weak acids? That's what we'll study now. Okay. Next is a strong acid. Strong acids. What are strong acids? An acid an acid which dissociates completely in aqueous solution. in aqueous. An acid which dissociates completely in aqueous solution is called strong acid. An acid which dissociates completely in aqueous solution is called strong acid. So you can write generally inorganic acids are strong acids. Generally, inorganic acids are strong acids. Example, HCl. HCl that dissociates completely into H plus and Cl minus in aqueous solution. Therefore, HCl is a strong acid. HNO3 that also dissociates completely to H plus and NO3 minus. Then H2SO4 that also dissociates completely into H plus and sulfate. Therefore, H2SO4 is also a strong acid. HCl, HNO3, H2SO4, they are all strong acids. So now can you write, based on this, can you write weak acids? Very good on evening. Very simple. In weak acids, how we can define? An acid which dissociates incompletely. An acid which dissociates incompletely in aqueous solution is called weak acid. Generally, organic acids are weak acids.
Yes, sir.
ಇದನ್ನೇ ನೋಡ್ಕೊಂಡು ಅದನ್ನ ಬರೀಬಹುದಾ weak acids, or should I write on the board weak acids? Hello everyone.
All right, sir.
Shall I erase this?
Yes, sir.
Everyone, shall I erase this?
Yes, sir.
Okay. Thank you. Weak acids. Weak acids. An acid which dissociates incompletely. An acid which dissociates incompletely in aqueous solution An acid which dissociates incompletely in aqueous solution is called weak acid. Generally, organic acids are weak acids. Generally, organic acids are weak acids. Let us take a few examples. Acetic acid, CH3, COOH. If any substance that dissociates incompletely, then it is represented like this. Double arrow, opposite. Okay. So if any substance dissociates incompletely, then it is represented like this. Hope that's clear. Sometimes it's also called reversible. Okay. CH3COH reversible, CH3COO minus aqueous plus H plus aqueous. Even phosphoric acid H3PO4. H3PO4. Though it is inorganic acid, ionizes incompletely or partially. That is why we use the word generally. Generally, inorganic acids are completely. That doesn't mean that all the acids will completely dissociate. Generally means few acids will dissociate completely. There are some exceptions. That is why we use the word generally. Then though this is phosphoric acid, inorganic acid, it ionizes or dissociates. Both are the same word. Dissociates incompletely, phosphoric acid. Phosphoric acid, H3PO4, 3H plus PO4, 3 minus. And hydrogen cyanide, HCN, that also ionizes partially, H plus Cn minus HCN. Or carbonic acid, H2CO3, that also ionizes partially or dissociates incompletely into H plus and CO3 2 minus. All these are the examples for weak acids. Hope that's clear. Shall I erase this? Hope it's clear to you.
Yes, sir.
Strong acids and weak acids. What are strong acids? An acid which dissociates completely in aqueous solution. That is strong acid. If it is strong acid, we'll show only one aroma that gives product. Weak acid that dissociates incompletely. Then we show like this, represent like this. Okay. And these are the examples for weak acids. Hope that's clear. Everyone, hope that's clear. Shall I erase that? Mata draw. Shall I erase that?
Yes, sir.
Yes, sir.
Next topic is basicity. Basicity of an acid. Basicity. Basicity of the acid. Basicity of the acids. What do you mean by basicity of the acid? The number of replaceable. The number of replaceable. The number of replaceable hydrogen atoms. The number of replaceable hydrogen atoms present in the acid. Present in the acid is called basicity of the acid. Basicity of the acid. The number of replaceable hydrogen atoms present in the acids is called basicity of the acid. Let me take HCl example. Example HCl. Now HCl has got only one replaceable hydrogen atom, right? Therefore, its basicity equals to 1. Basicity equals to 1. HNO3. This acid also has one replaceable hydrogen atom. Therefore, its basicity also equals to 1. H2SO4, sulfuric acid. It has got two replaceable hydrogen atoms. Therefore, basicity of sulfuric acid, basicity of sulfuric acid equals to 2. Correct? Phosphoric acid, H3PO4. Phosphoric acid has got 3 replaceable hydrogen atoms. Therefore, its basicity is 3. Basicity is 3. And even you can take carbonic acid, H2CO3. Its basicity equals to 2. Then CH3COH. CH3COH. Remember, in CH3COH, there are 4 hydrogen atoms, but all the 4 hydrogen atoms are not replaceable. ಅದರಲ್ಲಿರೋ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ನ ನಾವು ರೀಪ್ಲೇಸ್ ಮಾಡಕ್ಕಾಗಲ್ಲ. Only one hydrogen atom can be replaced, that is here, which is present at the last. Only this hydrogen atom can be replaced. Therefore, CH3COH, its base equals to 1. Okay. So what is basicity? It is the number of replaceable hydrogen atoms present in the given acid. If there are one replaceable hydrogen atom, then basicity is 1. Two replaceable hydrogen atoms, basicity is 2. Three replaceable hydrogen atoms, basicity is 3. Example for tribasic acid. Example for tribasic acid. Phosphoric acid. Example for dibasic acid. Sulfuric acid. Carbonic acid. Example for monobasic acid. HCl, HNO3, correct? All these are the examples for monobasic acid. Monobasic acid, dibasic acid, tribasic acid. All these classified based on the number of replaceable hydrogen atoms. Hope that's clear.
Yes, sir.
Hello, everyone understood? Everyone understood?
Yes, sir.
ನನಗೆ ನಿಮ್ ಕಡೆ ಯಾರಿಂದನೂ ರೆಸ್ಪಾನ್ಸ್ ಬರ್ತಾ ಇಲ್ಲ. ಎವ್ರಿವನ್ ಕ್ಯಾನ್ ಯು ಹಿಯರ್ ಮೀ? ಕೇಳ್ತಾ ಇದ್ದೀರಾ ನಾನು ಹೇಳೋದು? ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ?
Yes, sir.
ಏನಾದರೂ ಡೌಟ್ ಇದೆಯಾ?
No, sir.
Sir,
ಹಾ,
sir, can you explain this which you have written on the board? Sir, I had internet problems, sir. I couldn't attend.
okay. This is called basicity. What do you mean by basicity? Basicity is nothing but when an acid reacts with base. Okay, when an acid reacts with base, then basic radical of a base replaces hydrogen atom. Hydrogen atom present in an acid. So simply you can remember like this. Basicity is nothing but the number of replaceable hydrogen atoms. It should be replaceable, replaced by something else. So the number of replaceable hydrogen atoms present in the acid is called basicity of the acid. Understood?
Yes, sir.
Number of replaceable hydrogen atoms present in the acid is called basicity of the acid. Take HCl. In HCl, there is one hydrogen atom can be replaced. Therefore, basicity of HCl is 1. Since its basicity is 1, it is also called monobasic acid. HCl is called monobasic acid. HNO3. Here also there is one replaceable hydrogen atom. Therefore, basicity of HNO3 is also 1. Therefore, it is called monobasic acid. Got it?
Yes, sir.
Then H2SO4. H2SO4 has got two replaceable hydrogen atoms. Therefore, its basicity is 2. And it is also called dibasic acid. Phosphoric acid, 3 replaceable hydrogen atoms. So its basicity is 3 and it is called tribasic acid. And CH3COH at last. There are 4 hydrogen atoms. But remember, all the hydrogen atoms are not replaceable. Only one hydrogen atom is replaceable, that is present at last. Okay. Therefore, basicity of acetic acid is 1. Therefore, acetic acid is also monobasic acid. Hope that's clear.
Yes, sir.
So that's all about the acids. And in our next class, let me explain what are all the different indicators used to detect the acids. Then we'll move on to bases. Okay, hope that's clear. Everyone understood?
Yes,
Still,
sir.
Yes, sir.
Yes, sir.
Still, do you have any doubt?
No, sir.
Okay. Thank you. Thank you, everyone.
Thank you, sir.
Thank you. Take care. Bye-bye.
Thank you, sir.
Bye and thank you, sir.
Thank you.